Hi guys! This video is to explain about the basics of probabilities and statistics. So first of all, we will see the definition. Probability, this is defined as the number of favorable outcomes over the total number of outcomes. For example, let's say we are tossing a die. So when we are tossing a die, we've got 6 different outcomes. We could have either a 1, 2, 3, 4, 5, or a 6. So therefore, if I say, what is the probability of obtaining a 2? We can have only one time that we will obtain the number 2 over 6 different outcomes. So the probability would be 1 over 6. The probability of any event A happening will be always between 1 and 0. It cannot exceed 1. If A is the event A happening, we usually define A dash as the event A not happening. And what is this relationship with their probabilities? So probability of A dash would be 1 minus probability of A. So let's say if I say probability of event A happening is 0.6, what is the probability of the event A dash happening? So that will be just 1 minus 0.6, which will be 0.4. Now we are going to learn about some relationships that exist between union and intersection. When I say probability of A or B, this usually means probability of A union B. If I say probability of A and B, that would mean A intersection B. Now, what is the relationship? Probability of A union B, that will be probability of A plus probability of B minus their intersection. Now, let's look at the two different types of events. We have independent events and we've got mutually exclusive events, or sometimes called disjoint, that we will look at. So, two events are said to be independent if and only if the occurrence of one does not affect the other. For independent events, one very important thing that you will have to note is probability of A intersection B would be probability of A multiplied by probability of B. That is only for independent events. Now let's look at mutually exclusive events. Mutually exclusive events, or sometimes what we call disjoint. So this just means that if we have event A and B, they cannot happen at the same time. So two events are said to be mutually exclusive when they cannot happen simultaneously. So they cannot happen at the same time. So, in other words, if we have event A and B, their intersection would be just the empty set. So they cannot intersect. They would be, if this is two sets A and B, they would be completely disjoint. Now, in terms of probability, this just means that probability of A intersection B would be equal to 0. Let's look at example 1. So let A and B be independent events with probability of A equal to 0.38 and probability of B equal to 0.46. So the question is, find the value of probability of A or B. So when we look at the question, we have probability of A or B. So we immediately know that we are looking for A union B. And we know that A and B are independent events. So this means that A intersection B would be probability of A multiplied by B. So therefore, their union will be 0.38 multiplied by 0.46, which will give us a value of 0.1748. Now, our question is, what is A union B? So we are going to apply our formula that we learned above. Okay, so now probability of A is 0.38 plus B would be 46 minus the intersection that we just calculated based on A and B just being independent events, and we get a value of 0.6652. So that's how we solve it. So this is going to give us the probability of A or B happening. Now let's look at another example. Example 2. So example 2, let's say we've got two events, C and D, and they are independent events again. With probability of C happening is 0.1 and probability of C or D is 0.9. Now find the value of the probability of D happening. So what is the probability of D? We know that they are independent events, right? So first, we will write our equation. So C union D, this would be probability of C plus probability of D minus their intersection. Now C or D, this means the union. So the union is 0.9 equal to probability of C, this is 0.1. We don't know the probability of D, minus, now the intersection, since they're independent events, would be the multiplication. So it will be probability of C multiplied by probability of D. So we have 0.9 equal to 0.1 plus probability of D. This would be minus probability of C is 0.1 probability of D. Now it's just a matter of solving that. So 0.8 equal to, so that will be a 1 minus 0.1, which will give us a 0.9 D. And you solve that, that would be 0.8 over 0.9, which would be 8 over 9. So let's say that we've got A or B equal to 0.8, probability of A equal to 0.6, and probability of A and B equal to 0.3. Okay, so in other words, I can just reinterpret that as A union B would be 0.8, probability of A is 0.6, probability of A and B is 0.3. Now, just looking at the question, I already know that this is not disjoint. So this is not disjoint, because if it was disjoint, that probability should have been equal to 0. Since it's not equal to 0, it is not disjoint. Now let's find out if it's independent or not. So if it's independent, we know that the intersection should be a multiplication of both probabilities. So is that true? The first step is to find the probability of B. So we've got our equation. So that would be A plus B minus their intersection. So the union 0.8, probability of A 0.6, B we don't know, and their intersection 0.3. So as such, we can find the probability of B, which gives us a value of 0.5. Then let's multiply and see. Probability of A times probability of B, that is going to be, so probability of A was 0.6 times 0.5. This gives us 0.30. And is it the same as given in the question? Yes. Therefore, we will say that A and B are independent. They would be independent events because the product gave us the intersection. So now we are going to learn about conditional probability. First, we need to understand what this symbol means. So A/B, this means the probability of event A happening given that event B has happened. So event B has already happened in this case. Now, the formula for conditional probability, this would be equal to A intersection B over probability of B. So in general, it doesn't matter which type of events you have, whether it's A or B, it will be always the intersection of the events over the probability of the second event happening. So the second event here. Now, let's look at an example. So example 1, we have the probability of A occurring, let's say it's 0.2, the probability of event B happening 0.6, and the probability of event B happening given A has happened 0.1. And the question is, find the probability of B happening given A dash has occurred. To do this, we are going to draw our tree diagram. Tree diagram, so as you can see here, A is the first event that has occurred. So we have A dash, then we have B dash, B dash. So the probability of event A happening, so this branch here would be 0.2. So A dash, it would be 1 minus 0.2, which would be 0.8. Always the sum of the branches should be equal to 1. Now, we have the probability of B given it has occurred. So here, this branch A has occurred. So the probability of B would be 0.1. So this is the branch. This will be corresponding to B slash A. So the other one would be 0.9. And here, as you can see, that would be, let's say, X. That would be 1 minus X. So this branch corresponds to this branch here. This corresponds to B slash A dash. So the probability of B happening given A dash has happened. Now we will solve this. We have been given a key information here, which is the probability of B equal to 0.6. So probability of B, this can happen through A, or it could happen first through A dash, then B. So we have this branch, A first, then B, or this branch, A dash, then B. So therefore, we have 0.2 times 0.1 plus the second branch 0.8 times X. This would be equal to 0.6, the probability of B. So when you solve it, you will be having X equal to 0.725. Now let's take a second example. Example 2, we will have probability of A equal to 0.2, probability of B happening given A has happened probability of B happening given A dash has happened 0.1. the question would be find the probability of A given that B has occurred. So again, we are going to proceed by drawing our tree diagram. So we have A dash, and B dash. So the probability of A happening would be 0.2. This would be 0.8 then. The probability of B occurring given A has happened, so this is this branch here, this will be 0.6. So this becomes 0.4, which would be 1 minus 0.6. And we have the probability of B happening given A dash has happened, so this branch would be 0.1, and obviously this would be 0.9. Now, our question is to find the probability of A happening given B has happened. So in this case, we are going to use our formula. A intersection B, this corresponds to this branch here. So this would be 0.2 times 0.6 over the probability of B. So probability of B, this can happen through this or this. So it's going to be 0.2 times 0.6 plus the second branch would be through here. So 0.8 times 0.1. So solving that gives you 0.2 times 0.6 over 0.2, and this cancels out, giving you 0.6. Thank you guys for watching this video. I hope this has been an enriching and interactive one.